Good afternoon. Let us see an example problem on finding angle between two given curves. Okay, let us consider the curves. So two curves are given. First curve is 4x square plus 9y square equals to 45, and the second curve is x square minus 4y square equals to 5. Now you need to show that they are orthogonal. They are orthogonal. Okay, orthogonal means they intersect at right angles at some common point. Okay, so let us find a common point of the given two curves. Okay, so consider 4x square plus 9y square is equal to 45. Let us denote it by 1, and the other curve is x square minus 4y square equals to 5. Let us denote it by equation number 2. Okay, from equation number 2 we have x square equals to 5 plus 4y square. Now substitute x square in 1. Okay, we are finding the common point. Then it will be 4 into 5 plus 4y square plus 9y square is equal to 45. Then it is 20 plus 16y square plus 9y square is equal to 45. Then 25y square is equals to 25. It implies y square equals to 1, y equals to plus or minus 1. If y equals to 1 or minus 1, y square will be 1. So 4 into 1, 4, 4 plus 5, 9, x square equals to 9, then x equals to plus or minus 3. It implies x equals to plus or minus 3. Okay, whether y equals to plus 1 or minus 1, the x values are plus or minus 3. So the intersection points are 3, 1 and also minus 3, minus 1. Okay, if x equals to if y equals to 1, then x square equals to plus or minus 3. So the points are 3 and 1 is one point, and 3 minus 1 is the other point. If y equals to minus 1, then y square equals to 1, then x square equals to 9, x equals to plus or minus 3. So minus 3, 1 is the other intersection point. Our intersection points of two given curves. Okay, now at one of the common point, let us verify the given curves are orthogonal or not. Orthogonal means they must intersect at right angles at the common point. Okay, so in order to find angle, formula is tan theta equals to m1 minus m2 by 1 plus m1 m2. Okay, where m1 is the slope of tangent line to first curve at common point. Let us take the common point as 3, 1. There are 4 common points. I have taken only 3, 1. Okay, so the formula is dy by dx evaluated at 3, 1. Okay, for slope the formula is dy by dx evaluated at 3, 1. Now let us consider first curve, that is 4x square plus 9y square is equals to 45. Differentiate with respect to x. In order to get dy by dx, differentiate with respect to x. So 4 into derivative of x square 2x, 9 into derivative of y square 2y, internal derivative with respect to x, it is dy by dx is equal to 0. Now dy by dx equals to minus 8x by 18y, it is minus 4x by 9y. Okay, this is dy by dx. Now substitute to the point 3 comma 1. Now m1 is equals to dy by dx corresponding to first curve evaluated at 3 comma 1. Okay, so it will be minus 4 into 3 by 9 into 1. Minus 4 into 3 by 9 into 1, it is minus 4 by 3. Now m2 is the slope of the tangent line to the second curve at the common point 3, 1. Okay, now let us find m2. m2 is slope of tangent line to second curve at the point 3, 1. Okay, now take the second curve. It is x square minus 4y square equals to 5. Now differentiate this with respect to x in order to get dy by dx. Differentiate with respect to x. Now derivative of x square is 2x, y square is 2y. For y it is dy by dx is equals to 0. Then dy by dx is equals to, it is x by 4y. dy by dx equals to x by 4y. Now m2 is equals to dy by dx corresponding to second curve evaluated at the common point 3 comma 1. It will be x by 4y. It is x by x is 3 by 4 into 1. It is 3 by 4. Okay, now let us substitute these values in the angle formula. The formula is tan theta is equals to m1 minus m2 by 1 plus m1 m2. 1 plus m1 m2. Okay, now tan theta is equals to m1 value is minus 4 by 3. m1 is minus 4 by 3. m2 value 3 by 4 by 1 plus minus 4 by 3 into 3 by 4. Okay, if you see the denominator is 0. Okay, some finite value by 0, so it implies the possible theta is pi by 2. It implies curves intersect at right angle. Curve intersects at right angle at the common point 3 comma 1. At the common point 3 comma 1. That is, the curves are orthogonal. If the curves intersect at right angle at a common point, it implies that the curves are orthogonal at the common point 3 comma 1. Okay. There are several other common points like 3 minus 1, minus 3 1, minus 3 minus 1. You need not verify at all the points. It is sufficient if you verify orthogonality condition at one point. Thank you. Now let us see what is the sufficient condition in order to prove the curves are orthogonal. Okay, when do you say two curves are orthogonal? Okay, suppose the two curves are orthogonal. Okay, two curves are given and they are orthogonal. It means they are intersecting at right angle. That is, angle is pi by 2. Okay, now take the angle formula. Tan theta equals to m1 minus m2 by 1 plus m1 m2. Okay, now substitute theta equal to pi by 2. Theta equals to pi by 2 is infinity. Corresponding tan value is infinity, is equals to m1 minus m2 by 1 plus m1 m2. Then 1 plus m1 m2 is equals to m1 minus m2 by infinity. Okay. Then 1 plus m1 m2 can be taken as 0. Okay, finite value by infinity, let us take it as 0. Then m1 m2 is equals to minus 1. So it implies that if the product of slopes of the tangent lines to both the curves is minus 1, if the product of the slopes of the tangent lines of the given curves is minus 1, if the product is minus 1, then we can say that the two curves are intersecting at right angle, or the two curves are orthogonal to each other. Therefore, two given curves are orthogonal if m1 m2 equals to minus 1, where m1 is slope of tangent line, m1 is slope of tangent line to first curve at common point. Okay, similarly m2 is also slope of tangent line to the second curve at the common point. Okay, so if the product of slopes of tangent lines of the given two curves at a common point is minus 1, then we can say that the two curves cut each other at right angle. Thank you. Now let us see the topic increasing function and decreasing function. Okay, let us see the topic increasing function and decreasing function. Let us start with an example. If you take y equals to e power x, the graph of y equals to e power x will be an increasing function of this kind. Okay, so this is an example of, this graph is an example of increasing function. Suppose if you have taken y equals to 1 by x, y equals to 1 by x, then the graph will be a decreasing function, then the graph will be a decreasing function. Let us take some values. Okay, let us start with 1. If x value is 1, y value is 1. If x value 2, y value is 0.5. If x value is 3, y value is 0.3. If x is 4, y is 0.25. If x is 5, y is 0.20. Okay, let us denote 1, 2, 3, 4, 5 denoted by 0.2, 0.4, 0.6, 0.8 and 1.0. Okay, for 1 value is 1, for 2 it is 0.5, for 3 it is 0.3, for 4 it is 0.25, for 5 it is 0.2. Let us join all the points the curve. Okay, so this is the example of decreasing function. Okay, if you have taken example y equals to 1 by x, these are the points, and on joining the points, this is the graph we have obtained, and it is an example of decreasing function. Okay, exponential function can be taken as example of increasing function, whereas 1 by x can be taken as an example of a decreasing function. Okay. In general, the definition of increasing function is given by, suppose a function is given and some interval is given. F of x is a function defined on the interval I. It means x takes values from the interval I, and if its first derivative is positive for every x value in interval I, then we say that the function is increasing function. Okay, so f of x is a function defined on interval I. It means the function takes x values from interval I, then the corresponding first derivative value is positive for every x value in interval I, then we say that the function is increasing function. Similarly, if the first derivative value is negative for every x value in the given interval I, then we say that the function is decreasing function. Okay, for every x value in the given interval, if the functional value is negative, then we say that the function is decreasing function in the given interval I. Okay, this is the definition of increasing function, that is functional value derivative f dash x is positive. If it is negative, we call the function as decreasing function. Okay, then there is an alternative definition also. Suppose u comma v are two elements from the interval I. Okay, then if u less than v, correspondingly f of u is less than f of v, then we say that the function is increasing function. Okay, the alternative definition is u and v are two elements from the given interval I, and we have chosen two elements so that u less than v. If f of u less than f of v, then we say that the function is increasing function. Okay, the alternative definition for decreasing function is, again you have chosen two elements so that u less than v, correspondingly if f of u is greater than f of v, then we say that f of u is greater than f of v, then we say that the function is decreasing function. Okay, this is the alternative definition of decreasing function. So in general, we see that if the first derivative is positive for every x value in the given interval, then we say that the function is increasing function. If the first derivative value is negative for every x in the given interval, then we say that the function f of x is a decreasing function, and it is the alternative definition. Thank you. Now let us consider an example problem. F of x equals to x power 5 plus 20x minus 6. Okay, now you need to show that this function is an increasing function for any value of x. Okay, let us show that this f of x is increasing function for any x. Okay, so where x belongs to minus infinity comma plus infinity. Okay, now let us start with derivative. So derivative of f of x, it will be derivative of x power 5, it is 5x power 4, and derivative of x, it is 1, derivative of constant is 0, is 5x power 4 plus 20. Okay, now if f dash x is positive for every x value, then we say that function is increasing function. If derivative is negative for every x value, then we say that the function is decreasing function. Okay, so if x is positive or negative, since the power is even, x power 4 is always positive. Okay, whether x is positive or negative, x power 4 is always positive since power is even number. So positive number into 5 is a positive number. Positive number plus 20 is also a positive number. So the output is positive for any x value in the interval minus infinity comma infinity. Since the interval is not, he said it is for any x, so you can take the real number line or minus infinity to infinity. So for any x value in this interval, since the first derivative is positive, so we can conclude that the function is increasing function. Since f dash x is positive for any number in the interval minus infinity comma infinity, so you can conclude that f of x is increasing function. Okay, suppose if you have taken 0, then it will be 5 into 0, 0, 0 plus 20, 20, again it is a positive value. Okay, for 0 or positive value of x or negative value of x, this quantity is positive, hence we can say that the given function is an increasing function. Thank you. Let us take another example problem. A function is given f of x equals to 1 minus x cube minus x power 7. You need to show that this function is decreasing function for any value of x. Okay. Show that f of x is decreasing function. It is decreasing function for any x. Okay, for any x means x belongs to minus infinity comma plus infinity. Okay, let us start with derivative. Derivative of constant is 0 and derivative of x cube is minus 3x square and derivative of x power 7 is 7x power 6. Now it is minus of 3x square plus 7x power 6. Okay, so if x is positive or x is negative, x square is a positive term, x power 6 is also a positive term. Okay, then the term within braces is a positive term and the final answer is a negative value. Hence we can conclude that derivative is negative for any x in the interval minus infinity comma infinity. Okay, if x is positive or x is negative, x square and x power 6 both are positive for any negative x value or positive x value. The internal value is positive, into negative sign it will be a negative value, hence derivative value is negative, so you can conclude that the function is decreasing function. Function is decreasing function because first derivative is negative for any x value. Okay, for example, if the first derivative value is 0, okay, for example, if the first derivative value is 0 at some x value, it implies that at that particular x the function will have either maximum or minimum. Okay, for example, okay, suppose we have calculated derivative and correspondingly f of x naught equals to 0 for some x naught. Okay, so if if f dash of x naught is 0 for some value x naught, then we can say that the function has either maximum or minimum at the value x naught, and such an x naught is called critical number. Okay, it is called critical number. Okay, and the alternative definition for critical number is if f dash of x naught does not exist if f dash of x naught does not exist, where x naught is some number, then also x naught is called critical number. Okay, if f dash of x naught is 0, then we say that x naught is called critical number. At that value, the maximum or minimum of the given function may or may not exist. And there is another definition for critical number. The other definition is, if f dash of x naught does not exist, then also we can call x naught as critical number. Okay, if f dash of x naught does not exist, then also we can say that x naught is the critical number. Okay, so x naught is said to be critical number if f dash of x naught is 0 or f dash of x naught does not exist. So at that critical number, at that value, the maximum or minimum of the given function may or may not exist. Thank you. Now let us see another example problem. A function is given, function is f of x equals to 3x plus 5. Okay, now you need to find interval where the given function is increasing or decreasing. So you need to find an interval so that in the interval the given function may be increasing or decreasing. So for that, let us start with derivative. So derivative is 3 into 1 plus 0, it is equals to 3. Since 3 is positive, for any x value in the given interval, interval is not mentioned here. Let us take the interval minus infinity comma infinity. For any value in the interval minus infinity comma infinity, the function value f dash x is positive. Since f dash x is positive, for every x in the given interval, you can conclude that the function is increasing function. Function is increasing function. Okay, in the interval minus infinity comma infinity. Okay, so he is asking interval of increasing. So the interval is minus infinity comma infinity. Okay, so if you take any x value, from this interval, this value cannot be a negative value. If you take any x value from this interval, 3 cannot be negative. So for no interval, this function is decreasing. Okay, if you take any x value from this interval, this value cannot be a negative value. It implies for no interval, this function is decreasing function. Okay, so the given function f of x equals to 3x plus 5 is an increasing function in the interval minus infinity comma infinity, and there exists no interval, so that this function is a decreasing function. Thank you. Now let us take another example. F of x equals to x square plus 6x minus 11. So you need to identify an interval so that the given function may be increasing or decreasing. Let us start with the derivative. F dash x is equals to 2x plus 6. Okay, then it may be positive or it may be negative. So 2x plus 6 value may be positive or negative. It depends on value of x. Okay, suppose it is positive, suppose the quantity is positive, then 2x is greater than minus 6. Now divide both sides by 2, it will be x greater than minus 3. Okay, it implies that for the values more than minus 3, it implies that for the values more than minus 3, the function is increasing function. Okay, so f of x is an increasing function for the values more than minus 3, that is same as minus 3 to infinity. Okay, minus 3 to infinity. Okay, now this quantity can be negative also. it depends on x value. Suppose it is negative, it implies that 2x less than minus 6. Okay, it is 2x plus 6 less than 0. Subtract 6 on both sides, it will be 2x less than minus 6. Now divide both sides by 2, it is x less than minus 3. It implies that for the values less than minus 3, the function is decreasing function. For the values less than minus 3, the first derivative value is negative. For the values less than minus 3, the first derivative value is negative. It implies the function is decreasing function. So f of x is decreasing function for the values less than minus 3, that is same as from minus infinity to minus 3. So on the interval minus 3 comma infinity, the given function will be an increasing function, and on the interval minus infinity comma minus 3, the given function will be decreasing function. Thank you.